This video is supposed to be, or it is about temperature, but I'll start off with a different concept or conversation actually. So there is a very fundamental question that we need to ask before we actually start talking about this. See, till now we have been talking about mass, time, all of these quantities have been discussed. But we have to take a step back. So I'm going a step back and asking, how did you decide that something is measurable scientifically? For example, say I have this projector and I tell I like this projector. I like it. Second thing is, if I tell that this is a meter long projector, a meter long projector. Now my question to you guys is, how do we decide between these two? Or maybe not between these two, can be both also. How can we decide how do we decide if something can be measured scientifically? So this is a conversation we should have had before, but yeah, I kind of missed it. What does that mean? Say, is this more scientific or is this more scientific? This is right. But why do we call this as more scientific and not this? That's the question basically. This is not so scientific, not so sciencey. But this is S to this. The question is, why is this an S, but why not this? Well, it has passed a benchmark, and now I want to discuss about that benchmark. First is, the second statement is objective. So it's not about what I feel. It's not about what I feel or how I feel or what I feel. Second thing is, it is quantitative. That is, it is measurable. Right? You have a numerical value to it. You have a number associated with it. Third thing is, it is reproducible. So if I tell a meter long, can you guys understand how much is a meter? You can, right? You can just take up a measuring tape and measure a meter. So you'll understand how long, how big this is. Right? This projector is a meter long. You understand how long it is. If I tell it is around almost a meter high, that too you guys will understand. So this is around 1.5 meters high. So that too you guys will be able to understand. So if any quantity passes these three benchmarks, these three main benchmarks, it is a scientifically measurable quantity. For example, let me explain this. If I drink a hot cup of water with a bit of turmeric powder in the morning, that helps with inflammation. So if I tell, I drink this cup of water, and if I ask you guys, there's a possibility that some might find it not so hot. Some might find it very hot. Some might find it is actually cold or warm. Maybe not cold, but maybe warm. So all of these are what? These are subjective. It is your personal opinion. It's experience based. This is qualitative. These things are said to be qualitative. But if I point out that this is 60 degrees Celsius, this is not subjective. This is quantitative, objective, basically. This is objective and this is quantitative. Because it is reproducible, you can convey this to people through text, through conversation. But if I just do this, I need to add a whole lot of explanation, comparison, so that other person understands. So anything that passes this minimum benchmark and few more benchmarks, we can tell that it is scientific. So one of the ways of having this conversation or talking about a material is temperature. So that's a bit of background. So that's your temperature. So temperature is that quantity that passes this benchmark. It's not subjective, it's not qualitative, and it is precise actually. So why do we need to measure hotness? Everyday observation: when two objects are brought in contact, heat flows from hotter body to cooler body. Heat flows continuously until it finally stops, and that is basically we have achieved thermal equilibrium. But so when we talk about hot, cold, warm, it is subjective. It depends on personal feeling. Qualitative, it's not numerical. Not precise enough for science, basically. I can tell hot, you will understand, okay, you know what, oh, this will be around this, maybe about this temperature. Very hot, you might touch upon, it might be boiling water temperature, steam temperature. If I use those words, you guys will get a precise idea about what temperature I'm talking about. But it is not the right way to communicate. It's not an exact information, is not conveyed. So need of science, so defining temperature, why measurement is necessary. Science needs objective, quantitative and reproducible measurement for anything. So in this case, reproducible measurement of degree of hotness. And so we need temperature. So what measurement allows us to do this? What measurement allows us to do? Okay, basically, how does it help? How does this having this temperature helps? It will help us have a conversation about the direction of heat flow. It helps us compare things, right? So example, if I take a spoon which is less hotter, right? If it has a lesser temperature and I keep it inside the cup, what happens? Eventually, the spoon's temperature will also increase. So eventually the spoon will get hotter. And yeah, in time it will have the same temperature around 60 degrees Celsius. Do you guys agree? So that's about, first I compared it and then I'm able to measure it as well. And then I'm able to tell it that heat moved from the hot water to the spoon, stainless spoon. So to have this conversation scientifically, you need the idea of temperature. So all in all, condition for the physical quantity to satisfy that temperature satisfies is that same value in thermal equilibrium. If I tell two bodies do have the same temperature, they are said to be in thermal equilibrium. This is the basis for your first law actually. Zeroth law, sorry, not first law, zeroth law. So if I tell that, you know what, the spoon and the cup of water are at 60 degrees Celsius, you understand that they are in thermal equilibrium. You agree? Next, independent of material. If I tell 60 degrees Celsius, does it matter that this is water and this is steel? Right? This is liquid and this is solid? No, right? 60 degrees Celsius means 60 degrees Celsius. It is measurable and reproducible. So with this, only then the temperature becomes a true physical quantity. So with this, it becomes a true physical quantity like mass and length. Okay. So that's about a small introduction to temperature and the idea of what makes a quantity scientific. So what is a basic benchmark? So if you feel like writing anything from here, please do.